Hello, welcome back to the channel. So let's do one more question on volume calculation using definite integrals. And this question will be a fairly simple question if you know the steps on how to calculate the volume of solids using definite integrals and how to break down those steps of volume calculation. And this question is also similar to the previous question, the question that we did in the previous video. So if you have not watched that video, I would highly suggest you to watch the tetrahedron solid video in order to get the full context of this question. So let's move on to the question right now. We have been given that there is a solid V, we don't know about its shape. The solid V is 2 meters high, so we know the height of that solid is 2 meters, and the solid has square horizontal cross sections in this case. And the meaning of square horizontal cross sections is, similarly in the previous video when the tetrahedron was formed by stacking up equilateral triangles of decreasing sizes on top of each other, similarly in this case we have square horizontal cross sections which are being stacked onto each other in order to form the solid V in this case, which is 2 meters high. So now we know that the length of the side of the cross section at a height x meters above the base is 2 upon 1 plus x meters, and based on this given information we have to find the volume of the solid in this case. So again the same steps, we first identify the aerial strips in this case, and since we know that this solid is being formed by square horizontal cross sections, we know that our aerial strip would be a square in this case, right? And we also know that the solid is 2 meters high and the side length of that square formed at a height x meters above the base is 2 upon 1 plus x meters. So what it means is, you're basically, since 2 upon 1 plus x is a decreasing function, so what you're doing is you're stacking up squares of decreasing sizes, decreasing side lengths on top of each other in order to form the solid in this case. So we'll take an arbitrary aerial strip again, right? And we know the property of the arbitrary aerial strip, that the side length, for example, if this is our axis, for example, and if this is our arbitrary square aerial strip, we know that at a height, for example, if this is the height represented, at a height x meters above the base, we know that the side length of this square is 2 upon 1 plus x meters, right? And now we know that we have the side length and we have to calculate the area of our aerial strip in this case and integrate it over the endpoints, right? So we know that the side length which we can denote as A is 2 upon 1 plus x meters, right? And the area of our aerial strip, in this case, since it's a square, it's the side square, the area of a square is the side square, right? So the area in this case would be A square. In this case, A is 2 upon 1 plus x, so the area would be 2 upon 1 plus x to the whole square, right? So now we have the area, and we know that in order to calculate the volume, we either do integral A dx or integral A dy based on the variables that we have in our area representation, right? So in this case we have x, so we'll do A dx in this case, and in this case volume is integral A dx, which would be integral 2 upon 1 plus x to the whole square dx. Now the only thing that is remaining is the endpoints, right? So in order to identify the endpoints, we'll again use the given information in the question. So we know that the solid in our case is 2 meters high. So the height of our solid is 2 meters, and we are starting from the base, right? This is our base. So we are constructing squares from x equals 0 all the way to the height of the solid in this case, right? So we'll start with x equals 0 all the way to x equals 2 in this case, because 2 is the height of our solid being formed. And also a very important point, please don't get confused with this x over here. This is not the x that you have on the x-axis. This is basically the height in meters above the base. So this is an arbitrary height that you're taking above the base. So that is why this x is not something which lies on the x-axis. This is basically the height above the base in this case. So that is why we are starting from the base, which is of height x equals 0, all the way to the complete height of the solid, which is x equals 2 in this case. I hope that makes sense. Feel free to comment down if you still have any doubts in this part. Remember, again, this x is not the x that you have on the x-axis. Okay? So now we know the endpoints. We are starting from x equals 0 all the way to the complete height of the solid, which is x equals 2. And now this is your final volume in this case. If you solve this definite integral, you will be able to easily calculate the volume of the solid in this case. So that's it for this video. I'll leave the definite integral calculation to you. If you want a hint to solve this question, this definite integral, you can always use substitution. You can assume your u function to be 1 plus x and solve accordingly this definite integral. And remember also to change your endpoints based on your function conversions. So that's it for this video. Again, the important idea about these type of questions is to identify your areal strips, your most favorable areal strips according to the question demands, and then calculate the area of your areal strips and then integrate it over the endpoints that you are given in the question. So that's it for this video. I hope you found this video informative. Follow the channel in order to get notified about the other videos that I'll be uploading. Feel free to comment down in the comment section below if you have any doubts. Thank you so much for watching. Bye bye. Take care.